All right, welcome in or welcome back, everyone. Jake Dunn here with CGF, one of the UpStream developers, and I'm putting together this series of how-to videos for our UpStream tool that is in its public beta launch if you're watching this video. So our kind of first public release, finally getting this tool out into the wild. So this is the third of a four-part series. The first, if you remember, we did an overview of the tool, its interface, and the documentation. And then the second tool, we did sort of a whole building LCA, all of the modules for cradle to grave for a wood product. And this video is going to be looking at doing custom end-of-life scenarios. Let me go and share my screen real quick, and we can kind of talk about a diagram that shows the providence of this. So here we go. This is the three kind of areas of advancement that we think our tool is sort of contributing to wood product LCA for the architectural design community. The previous video sort of looked at doing, the cradle to grave LCA and kind of looking at where we could actually toggle between different biogenic starting points or different baseline assumptions to show how biogenic carbon in the product can be handled differently, and then also its end of life and understanding the sensitivity. This video is going to be focusing on number 2 here, the custom end-of-life scenarios with the 2 different data sets and how we actually build that in the model. And then the last video will be looking at adding in the forest, which we'll get into next time. So let's go ahead and jump into the actual tool. So if I pop back to our disclaimers and credits, just a quick reminder, if you have any questions or feedback on the tool in its current form, shoot us an email. At upstreamforestrylca@gmail.com, and we'll try to field those as quickly as possible. So jumping into the spreadsheet, and if y'all remember, I like to open up another window here so we can look at the results, updating with the inputs in real time until we evolve this into like an online tool that sort of, we have to do this within the spreadsheet this way. Hopefully you've got a little more screen real estate than I do in my work certain series. Okay. Anyway, here we are. So this is the analysis that we built last time. It's for the PA Living Building project, using that as our case study. We're seeing it populate all the different modules from, product stage to end of life, disaggregating everything, showing us where it's coming from, also comparing it against that baseline that we set. Here's the steel baseline. Here's the non-steel portions. Here's some of the sequestration that we're getting at the net out of the wood. And then here's what our overall savings is, roughly 50%. So the question is, what if we wanted to go into a custom end-of-life scenario? So if we drop down to our module C, you can see that we've actually stuck with the tally with biogenic carbon. Now you might be asking, well, what have we actually simulated? What are the assumptions behind this? One thing that we really wanted to do with the tool is diligently document that. So let's just run this through. If we wanted to check this out in the documentation, you guys remember this guy here. If I search for that input, it should drop us right down to that step 5 overview and inputs. Oh, this is the custom option. Oh, there's 2 of these. That's okay. I'll just go to the first one. Go. Yeah. So that should jump you to any input with end-of-life data source, or if you're searching for it, of course, you'll find some other. If there's other hits there as well, too, you could also search for it through this title as well. But this is step 5, calculating module C2 through 4, our end-of-life emissions. And then here's the different options that we're seeing here. So if we scroll down to what we selected, which was option 3, it'll start to give us information on what we simulated. So right off the bat, this tells us what those end-of-life distribution scenarios are that tallies assuming landfill at a certain percent, recycling and incineration, and sort of where that came from, right? So that's sort of giving us a clue there to where we could determine if we think that is representational or not. We've also, to kind of illuminate this, created this series of diagrams, which I'm sure we'll show in another video, right? These are the 3 initial options for the end-of-life scenarios and the biogenic starting points. Here's that tally version that we've seen. What we've done in this case is that we've looked at 2 different pathways for the custom end-of-life scenarios, either EPA warm or tally. You can see they actually have a different decomposition rate. And also they have different scenarios that you're afforded based upon which pathway you go down. But the idea is that you can input the percentage distribution here in case you had some different data that you were trying to simulate from. So that's sort of what's available, how that shows up in the tool. Let's take a look. Those back in. So if we flip this to custom, now it gives us a chance to pick one of our custom data sources. And so let's just say we're going to move to our EPA warm data set, and then we wanted to simulate Washington State's average end-of-life distribution, looking at some of the municipal data for CLT, let's just say. So if we put that in, that's roughly 40% landfill with landfill gas energy recovery. 24% is, whoops, not landfill with flare, but incineration. And then recycling is 36%. And yep, that should be 100. And now this starts to update our calculations in real time using that particular data set. It's also showing us the volume that we're simulating based upon what we input back up in step 1. So this now updates here, these values changed. We're getting sort of more savings just by going to that particular end of life distribution, but also the data set makes a big difference. We'll talk a little bit more about that later. But I wanted to show another output that becomes available once you go into the custom end of life data set. And that is this particular one here. And this starts to kind of give you some pretty detailed information about the scenarios out of the 5 that you've simulated and sort of how much is coming from non-biogenic emissions, biogenic emissions, module D if it's turned on, and what the overall net is. And this is really a useful chart because let's just say we wanted to simulate everything the same across all 3. It gives us some interesting feedback in that it will tell us right away sort of like from where of these 5 scenarios is that impact coming from. And you could start to look at, well, what is your most favorable end-of-life scenario based on this data set in case you wanted to try to optimize. And in this case, if we look at the nets, right, we've got landfill gas with energy recovery, with flare, incineration, recycling. Incineration has by far the most impact, the most GWP, kilograms of CO2 equivalent, primarily because, and we can see, it's that large biogenic emission. Once you burn that wood, you release all that carbon back up into the atmosphere. So that's being tracked here. And then all the landfills are pretty close. Looks like landfill with the energy recovery is a little bit lower. We're seeing that module D energy export come up just a little bit there. But that is the lowest over here. And then actually recycling is probably the most favorable in this case. We're starting to see where those impacts lie as well. So this gives you us really great feedback just unto itself. But let's go back to our scenario that we built based upon the Washington averages. It's 36. The other thing that is really, I think, valuable about this series of graphs is just sort of how the charts are nested and how you can start to really track where that impact is coming from. There's a lot of cases you actually don't even get this breakdown in some tools, right? Where it breaks it down between the biogenic emissions, from the product versus the non-biogenic emissions. So that I think is useful unto itself. But if you wanted to dig into, okay, well, out of those non-biogenic emissions, where did this 105,532 number come from? We come down here, it should equal the same here, green to green, non-biogenic emissions, and you can see exactly where that's coming from. Well, mostly on the recycling side, a little bit on incineration and a little bit on the landfill. Then you're like, well, where's this 184,671? What makes up that amount of non-biogenic emissions? We can actually go one level deeper, which is also really exciting. So I'm just going to scroll this out real quick. And then one of the kind of bonus tabs here is this end of life factor table. And this contains all of the different factors, calculations, and graphs for both data sets, either EPA warm or tally. And so if we stick with EPA warm is what we had chosen, and we look at landfill with landfill gas energy recovery, this is what that number is based on. So let's just true this up real quick. So the total is 18467. Let's make sure that is the case. And this is 10532. Oh, I'm sorry, no, it's 18467. This one, right, is what we're tracking back to. So that number is the same as this guy. and this is where it comes from, right? So we can see that there is landfill gas CH4 emissions, right? Because that's an anthropocentric emission from methane. It gets calculated as a non-biogenic. We're seeing the heavy equipment and transport make up that overall number. So we can actually break this down kind of 3 layers deep to give us a clear sense of exactly what we're simulating and how we particularly feel about those base assumptions, which is great. And we're also seeing that electricity credit come up with module D. We're also seeing the biogenic emissions show up, both as the landfill gas CO2 kind of leakage that comes out. We're seeing CO2 emissions that get converted from CH4 as it goes through the soil. This is part of the breakdown that comes out of EPA WARM, and how that all tracks through to the totals, and then finally the net. So lots of information. If you want to go that deep, super helpful as we were starting to analyze the sensitivity between these to be able to actually understand what you're simulating in general. So let's kind of break this back to this half and half. And I want to show folks just one more piece. If we flip this to tally, keep an eye on this recycling, right? It's 52718. If we flip this to tally, we sort of see that go up really high, and wanted to kind of figure out what exactly is going on there, right, as we start to dig into this. So let's kind of, let's see, I'm just gonna say this is module D, something that's happening. And it's like, well, why is there such a big emission? And I'm guessing we can go to the documentation and maybe read about exactly what's happening. Let's do our search again. This is the custom piece. Pick a custom data source, either EPA WARM, and then this goes through all of those EPA WARM scenarios and the factors tables for each of the scenarios. If you want to really read about how we mapped all that based upon those end uses, this is some good reading. And then we get into tally. We're interested in like what's going on with recycling. So we come down here. Here's scenario 3. Which is great. So it's showing there's no reprocessing emissions that gets passed along to the next LCA. Additionally, other emissions associated with transportation or biogenic emissions also get exported, so they end up as a credit. Holds true of biogenic carbon products as well, except since it's typically a credit, it becomes a large biogenic CO2 emission when it leaves the LCA scope boundary. So this is something that comes from how they interpret that LCA scope. The biogenic carbon in the product gets counted as an emission when it leaves the boundary in module D. So that's a really important piece that comes out both in the charts, because we're able to see them broken down at that level. And if you link it back to the documentation, you can learn more about what exactly is going on there in general. So that's great. And then notice too that when we switch to tally, we don't have the granular detail because it's a blend for the tally landfill. So that's really what we should have done in the beginning. So lots of different flexibility there. If you want to go down those rabbit holes, it's available to you. And it's also available in terms of learning a little bit more in that particular documentation. And of course, everything updates in real time, which is the beauty of it being a macro-free spreadsheet. So I think that's where we're going to call it on this. That's sort of how you build a custom scenario, kind of toggling back and forth between those two different data sets. And they have vastly different assumptions behind them. So I would definitely encourage you to check out the documentation so you can have a better sense of exactly what you're simulating when you make those selections. So join us next time for the last video in this installment, which is going to be on force factors. And just a reminder to send any comments, feedbacks, or questions to this Gmail address, and we'll try to field those as quickly as possible. So thanks so much, everybody, and we'll catch you next time. Thanks.